What we're going to do now is just a numerical example of this, okay? We are dealing now with a population with an unknown mean, which we will call mu. And this population also has an unknown variance, which we will call sigma squared. Now we have taken a sample of size 10 from this population, and I'm going to read out now the values we have got from our sample. So our values are 12, 8, 11, 10, 8, and 8, 13, 9, 11, 10. So those are our sample values. If you wanted to, you could call the first one, that's x1, that's x2, that's x3, then here that would be x10. So what we're going to do now is we are going to find unbiased estimators for mu and sigma squared. And if I use my other notation, I could say we are going to find mu hat and sigma squared hat, because that's what that means. So, from what we saw on the previous page, how do I find an unbiased estimator for the mean mu? What do I use as my unbiased estimator for the population mean that we don't know? Well, you just actually use x bar, because the expectation of x bar equals mu. Yeah. We use x bar. So x bar is simply add up all your x values and divide by how many there are. If you want to do that, you can do, or I can just tell you the answer. Mm-hmm. If you add those up, you get 100.
Is that divided?
So divided by 10, 10. Because the mean of our sample was 10, our unbiased estimator for the mean of the entire population is also 10. The other thing we need to work out then is our unbiased estimator for the variance, which is sigma squared with a hat over it. And this is the thing where we have that fiddle factor. We have the n over n minus 1 times by s squared.
Is this in the book, like in our green book?
This may not be in the green book, no, I'd have to check. And that s squared is the sample variance, and the formula for the sample variance, the easiest one to use, is that formula down there. I'm just going to pause there for a minute.